Two men stand at the center of a new industrial age. One is Elon Musk. He builds electric cars. He shoots rockets into space. He envisions a world filled with autonomous vehicles. He imagines humanoid robots. His factories are monuments to ambition. They are filled with machines that build other machines. The other man is Jensen Huang. He builds the engines of modern artificial intelligence. He makes the small, powerful silicon brains. They allow machines to learn. They allow machines to see. They allow machines to reason. His company, NVIDIA, forges the fundamental tools of the AI revolution. This is a quiet war, fought not with armies, but with supply chains, and fought with software. It is a contest for control. The battle is waged in the silent hum of data centers, and in the precise dance of factory robots. It is a struggle over who will define the rules for the dawning era of intelligent machines. Will it be the visionary who imagines the robots, or the engineer who builds their minds? To understand NVIDIA's power, one must first understand the Graphics Processing Unit, or GPU. Originally designed to render graphics for video games, these chips had a unique architecture. Unlike a standard computer processor, or CPU, which works on tasks one by one very quickly, a GPU is built to handle thousands of smaller tasks all at once. Think of it like a single master chef versus an entire kitchen of line cooks. The master chef is fast and precise on one complex dish. The line cooks can chop thousands of onions simultaneously. It turned out that the math behind training an AI was much like chopping thousands of onions. It involved countless simple, repetitive calculations done in parallel. NVIDIA saw this potential early. It did not just sell the hardware, it invested heavily in building the software that made its GPUs useful for scientists and AI researchers. This software stack, called CUDA, became the universal language for GPU computing. It created a powerful, self-reinforcing cycle. As more researchers used CUDA, they wrote more code for NVIDIA's chips. As more code was written, new researchers found it easier to start with NVIDIA than with any competitor. This created a deep and loyal developer base. The hardware and software became a single integrated platform, a complete system for building AI. This strategy culminated in legendary products. Tesla's ambition extends far beyond the electric vehicles it sells today. Elon Musk's ultimate vision is not just about sustainable transportation, it is about autonomy and robotics on a planetary scale. He sees a future where fleets of Tesla cars operate as self-driving taxis, generating revenue for their owners while they sleep. This concept, known as the robotaxi network, is the foundation of Tesla's sky-high valuation. It promises to transform the company from a car manufacturer into a high-margin transportation and AI service provider. But a car that can truly drive itself anywhere, in any condition, requires an AI of breathtaking complexity and reliability. This is where the need for chips becomes an insatiable hunger. To train its full self-driving software, Tesla must process petabytes of video data collected from its global fleet of vehicles. Every mile driven is a potential lesson for the AI. This data is used to train a massive neural network, a complex software brain that learns to recognize pedestrians, interpret traffic signals, and predict the behavior of other drivers. This training process is computationally brutal. It requires thousands of high-end GPUs running for weeks or months at a time just to create a single updated version of the AI model. What does it mean to be a gatekeeper in a technological revolution? It means holding a position of structural power. It is not about outright malice or a desire to crush competitors. It is about controlling a critical resource that everyone else needs to build their own dreams. By controlling the supply of the most advanced AI chips, NVIDIA wields several forms of power. Diagram: large gate labeled NVIDIA, with many smaller companies waiting to pass. The most obvious is pricing power. When demand for GPUs far outstrips supply, the seller can name its price. This allows NVIDIA to capture an enormous share of the value being created in the AI industry, turning the gold rush of others into its own guaranteed profits. Beyond price, the gatekeeper has the power to set the rules of the game. NVIDIA's software stack, CUDA, is the de facto standard for AI development. This means that legions of programmers are trained on NVIDIA's platform. Their skills, their code, their projects are all optimized for NVIDIA hardware. This creates immense inertia. Even if a rival chip maker produces a slightly better piece of hardware, a company might be hesitant to switch. Doing so would require retraining staff rewriting code. The technology industry is undergoing a profound transformation, a platform shift as significant as the move from desktop computers to smartphones. For the last 15 years, the smartphone was the dominant platform. Companies like Apple, Google became titans by controlling the operating systems. iOS, Android that ran on these devices. They built app stores, gatekeepers for software distribution. The winners owned the platform, the central nexus for everything. The economy was built around apps, mobile services, the data from billions of pocket-sized screens. Now, a new platform is emerging. Not a single device, a new layer of intelligence powered by AI in the cloud and on the edge. The most transformative products of the next decade will not be phone apps. They will be autonomous systems, self-driving cars, delivery drones, humanoid robots. The tension between a system builder like Tesla and a component supplier like NVIDIA plays out across several key battlegrounds. The most immediate is the supply chain. High-end GPUs are complex to manufacture and rely on a global network of specialized suppliers and foundries like TSMC in Taiwan. Any disruption, whether geopolitical or logistical, can create bottlenecks. Musk's decision to divert GPUs to X shows a direct conflict over a scarce resource. This is a zero-sum game. A chip that goes to one company cannot go to another. Securing a stable, prioritized supply of chips is a constant struggle for every major AI player. A second battleground is the move toward custom silicon. Frustrated by dependency and high costs, Tesla, Google, Amazon have each tried to design their own specialized AI chips. Tesla's Dojo is its primary weapon in this fight. The goal is to create a chip perfectly tailored to its own software and data, delivering better performance per dollar than an off-the-shelf NVIDIA GPU. If successful, this would be a major blow to NVIDIA's dominance. However, this is a high-risk, high-reward strategy. NVIDIA's dominance is not an accident. It is a fortress built upon three powerful pillars: supply, software, scale. The first pillar is control over the physical supply of its advanced chips. Manufacturing GPUs is one of the most complex industrial processes on the planet. It requires deep collaboration with a handful of specialized semiconductor foundries, most notably TSMC. NVIDIA's long-standing relationships and massive order volumes give it priority access to the world's most advanced manufacturing nodes. This lets it produce chips at scale and performance levels smaller rivals struggle to match, creating a formidable barrier to entry. The second pillar, software, is even more formidable. The CUDA platform is the bedrock of NVIDIA's empire, a rich ecosystem of tools, libraries, and APIs refined over nearly 2 decades. Millions of developers and researchers have invested careers in this platform. That creates a powerful network effect. The more people use CUDA, the more valuable it becomes, and the harder it is for competitors to break in. A rival would need more than a better chip. It would need a software experience so compelling it convinces an entire industry to switch and rewrite years of code. The third pillar is scale, which ties the other two together. By selling GPUs to a vast and diverse customer base, cloud giants, car companies, AI startups. Faced with this powerful gatekeeper, Tesla is not without options. Elon Musk is known for his aggressive vertical integration, and his long-term strategy is to reduce dependency on any single supplier. The most direct path is to double down on custom chip development. The Dojo project, despite challenges, is Tesla's best hope for independence. If engineering teams can build a training chip and an inference chip for in-car AI, significantly more efficient for Tesla's specific workload, Tesla could gain a sustainable competitive advantage and break free from NVIDIA's pricing and supply constraints. This is the hardest path, but with the greatest reward. A second, pragmatic strategy is to diversify suppliers. AMD, Intel, Amazon, Google, Tesla could design software to be more hardware agnostic. That would let it use a mix of GPUs from different vendors, reducing reliance on NVIDIA and increasing competition. This adds complexity to the software stack, but provides a buffer against supply shocks or punitive price hikes. The contest between Elon Musk's Tesla and Jensen Huang's NVIDIA reveals the new architecture of power in the 21st century. It is a story of a grand vision colliding with a fundamental dependency. Musk has the vision, the factories, the brand to build a future of autonomous machines. He is building the robotic bodies. Huang, however, is building their brains. In this silent war for the future of AI and robotics, the current balance of power is not equal. For now, the gatekeeper holds the stronger hand. Tesla's trillion-dollar valuation is predicated on solving autonomy. That solution requires a colossal amount of computing power. At present, the most efficient and accessible source of that power is NVIDIA. This makes Tesla a captive customer, vulnerable to supply constraints, price increases, and the strategic decisions of its most important supplier. While Tesla is fighting for its independence with projects like Dojo, building a world-class chip and software ecosystem from scratch is a monumental decade-long undertaking. Tesla is running a race, but NVIDIA continues to move the finish line. NVIDIA's position is fortified by its brilliant strategy of becoming the arms dealer for the entire AI revolution. By selling its powerful tools to everyone, Tesla competitors, it has made its hardware and software the industry standard.